Okay, so during the office hours this morning, there was a few things that were brought to my attention that might have been confusing and certainly my fault. And I apologize ahead of time because some of these things are a little bit hard to catch. It's easy when I'm face to face with you guys and one person has a question and I just address it pretty quickly, but sometimes on a video I don't realize what everyone's going to be questioning. So just a few quick things, bear with me, and hopefully this will help you with the finishing up the assignments here and really understanding them, which is the most important part. So I may have, when I was talking about the F critical in the z-test, so remember your F critical is just taking the larger variance divided by the smaller variance, and you're doing this to see if the variances are close enough to continue on with your z-test. So in order to do that, we have to compare that with our F critical from the table. So if we look at the table here, we know that on our stats, we have an N of 30 for each of these. All right. So for our table, we come back here, and V1 is the group that had the larger variance, and so we know we had 30 on that. But remember, this is degrees of freedom, so we take our n minus 1. So our degrees of freedom is actually 29. But since we don't have a 29 here, we need to round that to the 30. All right, so for V1, we're rounding to 30, even though our degrees of freedom was 29. However, for V2, again, we have an n of 30, which means our degrees of freedom is n minus 1 is 29. That we do have a number for, so we don't have to round. So we're using 29 here, and we're using 30 for the other one, so that's how the F critical becomes 2.09. All right, so keep that in mind with everything else, and hopefully that'll clear it up. I may have accidentally in my explanation jumped suddenly to 20 and 19. I'm not sure why. Just numbers getting wrong in my head, but the N was 30, so the degrees of freedom for both are 29, which means we round to 30 since we don't have a 29 for V1, and which means we use 29 for V2. All right, and then don't let that get confused with the F max. Right, so when we have ANOVA now, we have multiple groups, so now we have to use the F max. And the F max is the same idea. We're just making sure the variances are close enough to move forward with our ANOVA. And so this time you just divide the highest variance by the smallest variance, and that's your F max calculated. But for the F max critical, you have to use a different table. And so for the F max critical, that table becomes this one because now we have multiple groups. So now A becomes our number of groups. For the composts, it would be 5. And the degrees of freedom is just the minimum, and we have an N of 10. So for this group, these groups here, we had 1, 2, 3, 4, 5 groups. That's why our A is 5. And our replicates are 10, which makes our degrees of freedom 9. And so our cutoff for that, our F max critical, is 7.11. So that's the difference between an F test and an F max test. It's just whether you have comparing two groups only, like for the Z test, or multiple groups for the F max for an ANOVA. All right, so last couple of things. With the ANOVA, you're going to get your p-value. All right, and I'm going to jump over to the key here real quick. You're going to get your p-value, and we'll use the axolotl data together. That p-value is just telling us that there is a difference somewhere amongst these groups, right? But we need to do the Tukey's test to figure out where that difference is. So the T critical is just our minimum difference between two groups to know that that is different enough to be a real difference and not just random variation. So that's why we have to do these Tukey's kind of pairwise test. The ANOVA itself just tells us that there's a difference. Somewhere amongst these groups, at least one group is different from the rest, but it doesn't tell us which ones. That's where Tukey's comes in. It's telling us which pairs are different. All right. So when you get that with the compost data, you need to make sure that you figure out which composts are significantly different, or which pairs are significantly different from each other. If the p-value of the ANOVA was greater than 0.05, it means you can't reject the null hypothesis that they're all the same. So it means there is no difference amongst them, And if there is no difference amongst them, then you don't need to do a Tukey's because there was no differences anyway. So you're not going to try and find out which ones were different. None of them were different. But if the p-value is less than 0.05, then you have to figure out which ones were different from each other. But what I mean by bringing that back full circle, all right, so let's say that you find that there's a significant difference between compost A and the control. You have to go back and figure out what that difference is. All that means is there's a significant difference here. But presumably you're trying to help the plants grow larger. You need to then go back and see, did compost A make the plants significantly larger? Because if compost A killed all the plants, that's going to be a significant difference also, but it certainly changes your conclusion on whether you want to buy compost A or not. So the full circle means if you find there is a difference, you have to go back and tell me what that difference is. And then you would say something like compost A significantly increased the growth of the plants, or compost A significantly killed the plants and therefore don't use it. But you have to bring that full circle to the whole thing. If there is no difference, right? If you find two groups, maybe compost C versus the control are the same, or they don't fall above that Tukey's T critical value, then it would mean that compost C didn't help, and don't buy compost C. Right? All right, last thing, the two-way ANOVA with compost. This was something that I accidentally labeled, and I labeled them as heights. Heights is what's being measured, but the second variable is the gardener. All right, so one variable for our two-way ANOVA is the type of compost. The other variable is whether the gardener was Pip or Chris. So what you're really looking at is variable 1, did the compost make any difference? Did it matter which compost you used? Did any compost help? Variable 2, does it matter which gardener is doing the gardening? And then the interaction means, was one compost better for a certain gardener than another? And that interaction, put into better words, let's say Pip maybe is a gardener who doesn't water enough. Maybe compost A is actually really good at controlling water and helping conserve water. So compost A might work really well for Pip, but maybe not so much for Chris, who waters all the time anyway. But maybe compost C works better for Chris. That's the type of interaction. The compost that's best depends also on which gardener was working. That's your two variables interacting. But this is a two-way ANOVA because we have two variables. So again, the second variable is whether or not Pip or Chris. All right, and when you get your two-way ANOVA, it's going to call one of them columns. So the columns is whatever variable you put in the columns. It's going to call the other sample, and the sample is whichever one wasn't in the columns. And then it'll call the interaction variable, which is what we just talked about. All right. Last thing, real quick. Let me pull it up for you. Oops. All right, so after I had started all this, I realized that there was a question number 6 here. So if you see a question number 6 here on the one-way ANOVA compost data, ignore it. That is one of the things that I chose to not cover because of this online format. I know it takes longer to learn these things. So there's a few things I've been leaving out, and I didn't realize I still had a question on there. So I quickly went to fix that, I think on Monday or Tuesday, but if you had already downloaded the homework, you might see a question 6 here. You can ignore the question 6 that would have been right here. You do not have to answer that. All right? Hopefully all this is helpful. If you still have questions, as always, contact me. I'm more than happy to help. All right, thank you.